Okay, so on to the difference rule. 5 difference rule. So the difference rule is defined as, so if a function, if f of x is equal to p of x minus q of x, then the derivative, so f prime of x, is going to be equal to p prime of x minus q prime of x, which is the exact same as the sum rule as I mentioned before, except using subtraction. So in Leibniz notation, this is equal to d by dx of f of x is equal to d by dx of p of x minus d by dx of q of x. And we'll do an example right now. And this will be our example section. So we'll have 3 examples to do, easy, medium, hard. We'll start off with the easiest. So our first example, number 1, determine f prime of x, you can't see the prime, for the function, so for f of x, if it's equal to x to the 5 minus 9 to the x. Okay. So you can already tell that we're going to use the difference rule here. So we'll also need to use 2 other rules to find the derivative of each function. So here we'll use the power rule. So let's find f prime of x is equal to, let's find this derivative first. So using the power rule, we remember that we bring 5 out in front, and then multiply that by x, and then we'll do 5 minus 1 equals 4. So 5 times x to the 4. Now here we'll use the constant multiple rule. So we'll pull the 9 out in front, and then we'll use brackets. So we'll do, so there's a variable, there's 1 here, but we obviously don't write it, so we'll write 1 times x, and then 1 minus x is 0. So this is actually just equal to 0. So the derivative is just 5 times x to the 4th minus 9. Here we use the difference rule, power rule, and constant multiple rule. Next, we have a more challenging question. So let's differentiate the function. We'll differentiate f of x when it's equal to 2 over x to the 3 plus 4x to the 5 over 4 minus the square root of x. So we can already see we're going to have to use the sum and product rule. Sum and difference rule. Okay, now let's find the derivative. But wait, we don't really know how to do this yet. So what I like to do is to simplify this and put all the variables as one line, so we don't want any fractions, we don't want any radicals, so let's just simplify it. So we're going to rewrite f of x, is 2 times x to the minus 3, since we're bringing it into the numerator, plus 4x to the 5 over 4, that's fine. And we know that the radical, this is just equal to 1/2, so x to the 1/2. Okay, so although that doesn't look so pretty, it's a lot more doable, I feel, than using this. So let's jump right in to find the derivative. So first, let's take this. So we're gonna firstly we're gonna pull out the 2, constant multiple rule, times, bring the minus 3 here, times x. Minus 3 minus 1 is minus 4. Okay, now we're done that. We'll expand in the next line, but let's just do the first steps right now. So we'll bring the 4 out of it again, constant multiple rule, bring the 5 over 4 down, times x, and then 5 over 4 minus 1 is equal to 1/4. Now, minus, here's just the straight power rule. Bring the 1 over 2, x. 1 over 2 minus 1 is equal to the negative 1 over 2, so negative half. Now let's expand. So 2 times negative 3 is negative 6x to the negative 4 plus, this is turned out nicely. 4 multiplied by 5 is 20. 20 divided by 4 is 5. So we don't have a fraction as the constant in front here. Times x to the 1 over 4. And then this just stays as is. There's no constant. We need to multiply in. So we don't like having negative exponents, so let's simplify this one step further. So we'll go negative 6 over x to the 4th plus no negative exponent here, so we'll leave it as is. 1 over 4 minus 1 over, as you can see, 2 is in the denominator, so we put this here. And we know that this is just the square root of x. And there's your answer. Okay, now a more challenging application question. So let's determine the equation of the tangent of, determine the equation of the tangent at the point 1 minus 1 when f of x is equal to square root of x minus 2 all over. Yes, okay. So that also looks a little ugly. So we're going to want to simplify this again. So let's rewrite f of x as x to the 1/2. We don't need to do anything to the minus 2. So we'll just keep it as is. And then we're going to bring this up into the numerator. So it's going to be plus x to the 1/3. Perfect. Now we can start finding the derivative. So f prime of x is equal to, power rule again, 1 over 2 x 1/2 minus 1 is negative of half. And this is now the constant function rule. So this, we know that this is just equal to 0. So we don't need to write this in our next step. Now on to the next, using the sum rule. So plus, bring the 1/3 out in front. It's a power rule here. X, and then 1/3 minus 1 is minus 2/3. Okay, now we have negatives in the exponents again, so we're going to want to simplify. So if this, we'll do 1, 2 times square root of x. I'm going to do 1 over 3x to the 2/3. Perfect. Now this is the just general derivative, but we want to find the slope of the tangent at the point 1. So let's use this. So f prime of 1. And now we can substitute x for 1. So right away, let's do 1 over 2 square root of 1 plus 1 over 3, put the 1 in here, to the 2/3. So now we know that the square root of 1 is just 1, so this is just going to be a half. So 1 over 2, and then we know that 1 times any exponent is just equal to itself again. So that's just going to be 1/3. So now we're going to multiply this by 3, multiply this by 2 to find a common denominator. So that's going to be 3 over 6 plus 2 over 6 is equal to 5 over 6. So that's the slope of our tangent at the point x equals 1. Now we can finally find the equation of the tangent. So let's use slope point form. So y1 equals m times x minus x1. M is the slope at the given point. So y minus minus 1 is equal to 5 over 6 x minus 1. So using this as well. So this is just y plus 1 equals 5 over 6x minus 5 over 6. So let's multiply everything here, left side and right side, by 6 to get 6 out of the denominator. So 6y plus 6 equals 5x minus 5. And let's use standard form. So we'll have 5x, bring this to this side, minus 6y, and then minus 5 minus 6 is minus 11, and then that's going to be equal 0. And that is your equation of the tangent at the point 1 and negative 1. And that concludes our lesson for today, 2.2, derivatives of a polynomial function.